Hello, let's continue our Sudoku adventure with Brick Golem by rockratzero. So this begins our November theme week, and the theme is killer cages. You probably could have guessed, it's the only constraint in this puzzle. So every puzzle this week will involve killer cages. It'll highlight logic related to killer cages in some way. So some of them will be purely killer cages, and some of them will be killer cages plus some other constraints. So look forward to that. I know it's surprising we haven't done one yet. I mean, it kind of feels like killer cages are a very common constraint in this series in general, but I thought we would put a spotlight focus on them for this week. All right, so what are the rules? Well, we do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have cells in the grid that are surrounded by dotted lines. Those are called cages. And digits in a cage can't repeat. That's important because it helps narrow down the sums. You can also just be used directly. You cannot repeat digits. If this is a 1, this can't also be a 1. Normally Sudoku would allow that, but killer cages do not. In addition to that, there's a clue in the top left corner, and the digits in the cage sum to the value in the top left. So we could do, say, 1 or 2, 1, 4. 2 plus 1 is 3, plus 4 is 7. That adds to 7. That would be a valid way to fill this killer cage. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, so I've talked about this a lot in this series, but I think it's really nice for the first puzzle of a killer cage series to talk about how to think about restricted sums. So there's the super restricted sums where there's only one possibility, and it's always going to be the minimum cage total and the second to minimum, and then the maximum and the second to maximum are always going to have only one way to fill them because we can't repeat digits. So let me go over how you can think about that. Well, in this case, we're a 6x6. This works in any size Sudoku though, but in this case, we're a 6x6. So the smallest two digits we could put in are 1 and 2, right? Because we can't repeat digits. So the smallest two are 1 and 2. That adds to 3. So the smallest cage we could possibly have is a 3. And you can see that 3 is always going to be 1 plus 2. We don't know what order. We don't actually have a 3 cage, so I'm just pretending there's one here. But in addition to that, I told you that the second to minimum is also going to be one possibility, and that's the 4 cage. And the reason for that is we need to add 1 to one of the 1 or 2 in order to make the sum 4 instead of 3. And if we try to add 1 to the 1, well, now we'd have 2 2s, and we're not allowed to repeat digits in killer cages. So the only digit we can add 1 to is the 2, and so we end up with 1 3. So a 4 cage can only be 1 3. You can also work backwards. So 11 is going to be the biggest, because the two biggest digits we have are 5 and 6. Those add to 11. So that's the only way we can do 11. If we had a 10 cage, we'd have to subtract 1 from the 5 or the 6. Can't subtract 1 from the 6 because we can't repeat the 5. So we'd have to subtract 1 from the 5, and we end up with 4 plus 6. So we end up with this 1 3 and this 5 6. 9 is interesting to me because so once you get down to the third to maximum or the third to minimum, now you have 2 ways to add to it. And we're talking about dominoes in this case. And so for 9, for example, this is, remember, 11 was only 5 6 and 10 was only 4 6. So we need to subtract 1 from 4 6 in order to get 9, right? And we can subtract 1 from the 6 to get 4 5, or we can subtract 1 from the 4 to get 3 6. So those are going to be the only ways to add to 9. But notice 3 6 is not possible here because we already have a 3 in this 4 cage down here, the 1 3 pair. So we're going to have to, we cannot actually use the 3, so we're going to have to leave the 4 alone and make it 4 5. And now this is another really nice trick for, and I do see the 7 cage, by the way, but we're not going to do that yet just because I want to go over the domino logic first. So now this is another really nice logic that can be done with, usually done with dominoes, can be done with more, which is, remember, there's 2 ways to add to 9. There's 4 5 or 3 6. But what would happen if I made this 4 5? Well, now this column would have too many 4 5s. Right? We can't spread them. We can't spread 2 digits across 3 cells. And so the key thing is, if there's 2 ways that a domino can add, or just in general, if two of the same domino sum, if one of the cells sees an entire other domino, like this sees this entire domino, they cannot have matching sums because both of these digits would be removed from this cell here. And so the point is that this has to be 3 6, and we know that this can't be a 3. So this is 6, this is 3, and the entire column finishes with a 2. All right. Now 7 is very middling. There's actually initially for a 7 domino, there's 3 ways you can add to it. You can do 1 plus 6, 2 plus 5, or 3 plus 4. And that uses up all of the digits, so there's no way to really even mark it. What we do see now is that we can't put a 2 here, but there's an even nicer thing we can do in a 6x6, which is we know that 3 and 6 end up down here somewhere. So anytime you have a domino and a domino and they have different sums, you will know basically a really nice restriction on the other domino, because this 3 and 6 need to end up down here somewhere, 3 and 6. And we know this one's not 6. I don't know if that's helpful, but let's ignore that for now. Now we know that both 3 and 6 are not going to end up down here, because then it would add to 9, and we know it adds to 7. So we're going to use a 3 or a 6 to add to 7 is the key. And then the other one's going to end up over here, meaning that this has to be one of the 3 or 6s. And then if we're using a 3, we'd have to do 3 plus 4. If we're using a 6, we'd do 6 plus 1. And unfortunately, this 2 is telling us the same thing, but I just thought I'd point that out, that you know that one of these digits ends up over here. And then you also know that the digit that adds to 7 is going to end up here. So we're going to end up with the 1 or the 4 right over here. So that's some nice logic you can do. All right, let's look at the 5 cage as well. So 5, it's 1 higher than 4. So from 1, 3, we need to add 1. So we can do 2, 3 if we add 1 to the 1, or we can do 1, 4 if we add 1 to the 3. So this is from 1, 2, 3, 4. We don't know the order. This 5, 6 pair does remove 6 here from here, by the way. So if this cannot be 6, this cannot be 1. So if these add to 5, then these also add to 5, because if you think about it, we're using up 1, 2, 3, 4, and we're using up 2 of the digits that add to 5 here. So these other 2 digits that are from 1, 2, 3, 4 will also add to 5. You could also sum up the column. If you sum up the column, rows, columns, boxes always add to 21 in a 6x6. So they have 1 through 6 in them. 1 through 6, if you add up 1 plus 2 plus 3 plus 4 plus 5 plus 6, you get 21. And so we can subtract 11 and 5 from that. If we subtract 16 from 21, you get 5. So these add to 5. So this is going to be either 1 plus 4, or 3 plus 2, or 4 plus 1. All right, let's talk about 3-cell cages now. So the minimum you can put in a 3-cell cage is 1, 2, 3. We're ignoring that this 3. We're just doing this in a void, because we're not going to be using 3 anyway. So just like the 2-cell cages, right? 1, 2, 3, that's a 6-cell cage. The 7-cell cage is also going to have only one possibility, because we need to add 1 to one of these digits. But if we add 1 to the 1, we end up with 2 2s. And if we add 1 to the 2, we end up with 2 3s. So that's not going to work because we can't repeat digits. So the only digit we can add 1 to is the 3. And we end up with 1, 2, 4 being the only way to add to 7 in some order. That does give us a 1, 2, 4 triple in this row. Basically, the question is, where does 5 go in this row? And that goes there. In fact, we could have seen that already, that 5 needs to be placed here. So 5 ends up in one of these two. Now let's think about 14. So what's the biggest we could add to? Well, 4, 5, 6 are the 3 largest digits, and they add to 15. So we need to subtract 1. Again, can't subtract 1 from the 6, can't subtract 1 from the 5. So the only way we're doing this is 3, 5, 6. You can see this 3 takes 3 out of these two, so that's our 3. And then this can't be 6 because of the box, so that's 5 and that's 6. Now this 3 does remove 3 from here, and remember that it needs to add to 7, so that removes 4 from here. This 6 gives us the 5, 6, and this 3 gives us the 1, 3. This can't be 5 anymore, this can't be 3. I'm not worried about these corner marks anymore. Okay, just want to show off as many tricks as I can because it'll be useful for the rest of the puzzles today, this week, not today. This is a 1, 4 pair just for the box. This 4, 5 pair does remove 4 from here. I should note that. So this 7 cage has a 4 in it, and it's in this cell or this cell. So you can point from killer cages. This is another really nice technique. So Rockrat's actually showing off a lot of good stuff, or at least taking advantage of being able to show it off, even if it's not necessary. So if one of these two is 4, that means this cannot be a 4, or we wouldn't be able to put 4 in this cage. So this can't be 4, meaning it's 6. That gives us the 1, and the 3 here gives us the 4 and 1. These are not 1s. These are not 1s. So remember, these add to 5. So this is 1 plus 4. This is 2 plus 3. That does make this a 2, 1, and 4 to finish the cage. That's 5 and 4. All right. We have filled out all our killer cages, so we know it's just going to be Sudoku now. It's probably a pretty simple Sudoku. These 3 digits are going to be 2, 3, 6. This is not 6. This is only 2, 3. In fact, it's not 3 either. So that's 2, 3, and 2. So this is going to be 3 and 6 in this order. So this 3, 5, 1, we need to put 1 and 5 here. So this 5 says that's 1, that's 5. Let's see, this row. Oh no, let's finish this cage first. Or sorry, let's finish this box first. I said cage too many times today. We need a 2 and a 4 here. This can't be 4, so that's 2 and 4. And then I need a 2 and a 1 down here. And I need a 4 and a 5 down here. And we're done. All right. Nice demonstration of the forced cages, Rockrat. Actually, that gave me really nice opportunities to talk about dominoes, to talk about 3-cell cages, talk about mins and maxes. We also got to point from a cage, which was nice. And we also got to talk about, at least in 6x6s, how domino here and domino here can be taken advantage of to reduce what markings we have. It's especially powerful if this was, say, a 9 and this was an 8, by the way. Cool. Well, hope you enjoyed that. Hope you learned something about killer cages, or at least reinforced things you've already learned. And let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.